Okay, this is number 11, another problem where they ask us to compute the implicit derivative dy dx. The main reason I wanted to do another one is just to let you know that there are some nice things about implicit differentiation. You're going to see it in this one. Now, remember what we typically do. We just take the equation as it is, and we take the derivative of both sides. Okay. But here's what you might notice right away with this one. Taking the derivative of 1 isn't a big deal. Okay, but if you take the derivative of this side, I mean, look at that huge mess. It's a fraction, so we already have to use the quotient rule. And inside the numerator and denominator, I've got some x's and some y's. So it might be kind of a complicated mess to compute the derivative using the quotient rule. Okay, you can do that. Okay, but if you want to avoid it, one thing you're allowed to do, since this is an equation, you can use any rule of equation manipulation to rewrite it in a way that looks better. Okay, so what I would do in this one, make it a little bit easier for the derivatives, I would just start by multiplying both sides, okay, by 2x minus y. Okay, that's a rule of equation manipulation, right? You can always multiply an equation, both sides of an equation by an expression, you get the same thing. Okay, so over here those two cancel and I get just x plus y, and on the right side I get 2x minus y. Okay, this is a lot better looking. It's basically equivalent to what we started with, as long as 2x minus y isn't 0. But working at this point, it's so much easier because we don't have any quotients. Okay, we don't have to use the quotient rule. So just rewrote the equation there, and now I can start computing the derivative of both sides. Okay, and I think you'll see that this is a lot easier looking now that we've rewritten it. So I have the derivative of the left side. Well, the derivative of x with respect to x is just 1. Okay, the derivative of y with respect to x is dy dx. Okay, right? Just y is a function. What do we call its derivative? We call it dy dx. Okay. Over here we've got the derivative of 2x, which is just 2, since we're taking the derivative with respect to x, minus the derivative with respect to x of y, which is another dy dx. Okay. Yeah, all we have to do in this equation is solve this for y. So solve it for dy dx. So if you can look, we've got two dy dx's. We need to move them to one side. We need to get these constants over to the other side. So I'll subtract 1 from both sides, and I'll add dy dx to both sides to get those terms to one side. And it looks like what I'll have left is 2 times dy dx. Right, I've got 2 of those added together, equals 1. So dy dx, just divide both sides by 2, equals 1/2. Okay, so despite being, if I go back to the original equation, despite looking somewhat complicated, what did we have? Something like x plus y over 2x minus y. Not very complicated at all. The derivative of this function is just 1/2.